Alright, in this video we're going to check out how to fill out the unit circle with some easy tips and tricks. Now if you want to know how the unit circle is formed or where these numbers are coming from, you might want to check parts 1 through 3 of this video. But in this video we're just going to fill it out nice and quickly. Now this is what an empty unit circle looks like, and we're going to fill this out in 3 stages. First, we're going to take care of the degree measurements, which are on the inside. Then we're going to fill out the radian measurements, which are further out, and then we're going to take a look at all of the coordinates. Now, as we're doing this, keep in mind that the unit circle is on an x and y axis. So as we go to the right, x is positive. And as we go to the left, x is negative. As we go up, y is positive. As we go down, y is negative. And these points on the edge are intercepting on 1 and -1 on the x and y axis. All right, so let's check it out. All right, to label degrees, we're going to start with 0 on the positive x-axis. Keep in mind that large sections are worth 30 degrees and small sections are worth 15. So we start with 0, we go through a large section, which brings us to 30, then a small section, so if we add 15 to that, that's 45. We add 15 to that, that's 60, and then another 30 will bring us to 90 degrees. Every time you reach one of the axes, one of the x or y axes, it's good to check to make sure that you're either at 90, 180, 270, or 360. That helps to keep you in check along the way. So we're just going to keep going around. We'll go. So big section is worth 30, so we're at 120, then 135, then 150, then 180, 210, 225, 240, 270, 300, 315, 30, 360. And that's the full way around. Now we also have 0 for radians, where there are 0 degrees. And let's fill out the rest. So we're going to label the radians from the top, 2, 3, 4, 6 as the denominator. So we have pi over 2, pi over 3, pi over 4, pi over 6. We're going to cut across, down, and across again to match the same denominators. We're going to count to get to the numerator, skipping numbers that will cancel the denominator. So here's what I mean by that. So as we move across, you'll see that the radian measure at 120 will be something pi over 3. Now we're going to start counting. The number after 1 is 2. So the next one is 2 pi over 3. All right. Now this is a shortcut. If you go ahead and convert 120 degrees into radians, you will get 2 pi over 3. Now if we cut across here from the middle one, we're going to get something pi over 4. So we're going to count 1, 2 would reduce to pi over 2. We already have pi over 2, so you're not going to count 2. So the next number after that is 3. And then we're going to go across from the pi over 6, which would be something pi over 6. So we're going to count 1, 2 will cancel, 3 will cancel, 4 will cancel. So the next number is 5. Now another way people like to look at this is it's 1 less than a denominator, because here we have a full pi. So if we have a full pi down there, then that, if you express that as a fraction, let's say of 6, it will be 6 pi over 6. 1 less than that is 5 pi over 6. If you express it as a fraction with a 4 at the bottom, that would be 4 over 4. 1 less would be 3 over 4. If you express it as something over 3, it would be 3 over 3. 1 less would be 2 over 3. So you can think of it as 1 less, or you can do the counting method. I'm going to continue doing the counting method and show you the 1 less and 1 more method as we go along. So let's fill out the whole thing now. So I'm going to do all the pi over 6's. So as we go down, we get something pi over 6. So we left off at 5, so the next number is 6, then the next number is 7. Because we can't use 6 because it'll cancel out. So that's 7. And then when we go across, we're going to get pi over 6 again, but we're counting from 7, 8 would cancel, 9 would cancel, 10 would cancel. So the next number is 11. We go down from here to fill out the pi over 4 family. So it's something pi over 4. We left off at 3. So the next one would be 4, which could cancel. So the next one would be 5. And then we go across again. So it's something pi over 4. 5, 6 would cancel. So the next number is 7. Go down. So this is going to be something pi over 3. We left off at 2. So the next number was 3, 4. And we go across, next number would be 5. And that would be it for radians. You just filled out the whole unit circle in radians. Now in the bottom left quadrant, over here, that would be the 1 more quadrant. So again, if I looked at pi as being 6 pi over 6, 1 more would be 7 pi over 6. For the 4 pi over 4, 1 more would be 5 pi over 4. And for 3 pi over 3, 1 more would be 4 pi over 3. So that would be the 1 more. In the last quadrant, in the fourth quadrant, this would be 1 less than double. Remember, a full turnaround would be 2 pi radians. So 2 pi would be the same thing as saying 12 pi over 6. So 1 less than that would be 11 pi over 6. Double as far as pi over 4 would be 8 pi over 4. 1 less would be 7. And then for pi over 3, it would be like 2 pi would be like saying 6 pi over 3. So 1 less would give you 5 pi over 3. So either count or use the 1 less and 1 more. Now we're going to take a look at labeling the coordinates. Now, labeling the coordinates is as easy as 1, 2, 3. All right, so we're going to go down 1, 2, 3, and we're going to go back up 1, 2, 3. So those would be my numerators. I'm going to go ahead and put a denominator of 2 for all the coordinates. And then I'm going to square root the top. Remember, square root of 1 is 1, so I don't have to put a square root over the 1. So it gives me root 3 and the root 2's right there. So it's very simple. Keep in mind we are on an x and y axis, so that x-intercept at 0 is going to be 1, 0, and that y-intercept over by 90 degrees is going to be 0, 1. Coordinate 0, 1. 0 for the x, 1 for the y. Alright, so now we're going to do the same thing that we did with the radians, which is to go across, down, and across. And we're going to end up getting the same coordinates, except because of where we are on the x and y axis, some of these coordinates will be negative and some of them will be positive. So going across, if you look at the pi over 3, we get the same coordinates, 1/2 and root 3 over 2, except the x coordinate is negative because we are to the left of the y-axis. Now the y coordinate is still positive because we are above the x-axis. So we are in the coordinate system where in this quadrant, you'll have negative x values and positive y values. So it's the same, root 2 over 2 and root 2 over 2, except the x coordinate is negative. And for the pi over 6's, we get the same coordinates, root 3 over 2 and 1/2. except the x coordinate is now negative. All right. Now we're going to continue going down and across. So let's see what we have next. We have the pi over 6. We go down. Now that we're in the third quadrant, we are to the left of the y-axis and below the x-axis. Both coordinates are going to be negative. So we have a negative x coordinate and a negative y coordinate. You'll notice that they're the same in value, only now it's negative. And if we go across, we are now positive because we are to the right of the y-axis. The x coordinate is now positive, but we are still below the x-axis, so the y coordinate is going to be negative. So we have root 3 over 2 and negative 1/2. So let's try this again with the pi over 4 family. So you see how at pi over 4 we have coordinates root 2 over 2 and root 2 over 2 right here. When we go across, we have the same coordinates, but one is negative. Now we're going to go down, and now we're going to have the same values, but both will be negative. So we have negative root 2 over 2 and negative root 2 over 2. We go across, the x coordinate will be positive, the y coordinate will be negative, and then we're going to go all the way around with our pi over 3s. So we go down, same coordinates, both negative, across, same coordinates, the y is negative. That's it.